Hello everyone. As part of learning big data with Hadoop and Spark, today we will be talking about pig, right? So whenever you are trying to learn pig, we'll be learning various concepts like pig Latin, grunt, so various things. Let us see what exactly is this and how it is helpful, because we have already learned the concepts of storing the big data and processing the big data. Now we are looking at how this particular tool is helpful after learning all those things. Now Apache Pig, so as the name says, it is coming from the Apache Pig. It gives a level of abstraction for processing large data sets without having to write MapReduce. So by this time you people might have realized how complex it is to write a MapReduce program, because you need to import so many packages, you need to write the mapper, you need to write the reducer, you need to write the driver, and there are various objects which we need to remember, the order of these statements. So by this time you have understood the little bit of complexity that is involved in writing the MapReduce programs. So when we are working with pig, it helps us to process huge amounts of data sets without having to write MapReduce programs. This is the first advantage we feel, right? Then it raises the level of abstraction for processing large data sets. With MapReduce, it is what the programmer is trying to do is, he is trying to specify a map function followed by a reduce function, but working out how to fit the data processing into the pattern, everything we need to write under map reducing program. With pig, data structures are very rich, where we will see various data structures that are built into pig, which will help us to work with them directly without having to write again. And they are working with multi-valued variables, you can work with nested data structures, and various built-in transformations are available using which you can transform your data from one format to another format. And you can try to get the results which we want very quickly with less number of lines of code. I will show you with some examples also. Now, pig is also including built-in joins. In MapReduce, we need to write a very big program if you want to work with joins. I'll just give a quick brief of working with joins in MapReduce. Whenever we are working with join, we try to extract data from multiple tables or multiple occurrences of a single table, self-join. You are joining a relation with a same itself, right? So whenever you are trying to extract data from multiple instances of tables using join, you need to write those many mappers. Say for example, I am trying to join employee table and department table, which we know in Oracle, right? So you need to write a map method to extract data from employee file. You also need to write a map method to extract data from department file. Then you need to write a join method, then reducer, then driver. The number of methods or programs which you are writing will increase as and when you are working with joins, Cartesian products, various numerical functions like standard deviation and all. We call them as design patterns in Hadoop, right? So when you are working with pig, join is a built-in operation, so it reduces the complexity on the part of the user, right? Then pig is made up of two parts. What are the two parts? First one, we call it as pig Latin, which is the language we use to express in order to get the data whatever we want, and execution environment to run the pig Latin programs. And there are two types of environments right now available: local execution in a single JVM, and the other one is distributed execution in Hadoop cluster. There are two modes of environment, and the first one is the pig Latin language. Total, you are talking about two parts of the pig. First one is the language which you are using in order to express these statements. Second one, the environment where you are executing. There are two environments as mentioned, local as well as distributed. Now, pig Latin program is made up of a series of operations or we call them as transformations. Most of the time, more than operation, we use the word transformation, and they are applied onto input data in order to produce the output. The operations, they describe data flow. So whenever you are working with pig, we say I am analyzing the data flow, or pig is a tool for data flow analysis, right? So the execution environment, whenever the input data is flowing, pig execution environment translates it into executable representation and then executes. Now, whatever transformation operation we are writing in pig language, under cover or background, in the background, it is automatically converted into a MapReduce program. Try to understand, previously you were writing a MapReduce program, now you are just writing one single line using pig Latin, that is the language, and in the background the pig engine is automatically converting the transformation into MapReduce program. A big burden is relieved from the user. Now the user is not having the burden of writing a MapReduce program. Instead, you write one single line. In the background, the pig Latin automatically converts it into a MapReduce program. Are you understanding? Yes. Then, under the covers, pig turns all the transformations into a series of MapReduce jobs, but the programmer is not aware of this. What as a programmer we feel is, I have written a line, I got the output. But what exactly is happening inside? It is trying to convert whatever single statement we have written into a MapReduce job. Single statement or maximum 4 to 5 statements, those are converted into a series of MapReduce jobs. So the user, because he is relieved from the burden of writing a big MapReduce program, he can concentrate on the data flow and he can analyze than simply bothering to write the big programs. And pig is a scripting language to explore large data sets. We are trying to explore huge amounts of data sets using the pig Latin, which is the language. Why did they go for this? Because people started criticizing MapReduce has a huge development cycle. You need to write a mapper, you need to write a reducer, you need to write a driver, then you need to add the external jars, then you need to export the file as a jar file, then you need to remember a big command of executing the MapReduce program. You need to know where your input file is there, where the output file, etc. These are the complexities which generally people feel with MapReduce. And why pig has become so popular in spite of MapReduce existence? Because its ability to process terabytes of data in response to half dozen lines of pig Latin issued from the console. Normal, you don't go to any editor, you don't write any big programs, hardly never we see any program with more than 10 to 12 lines in order to process the complete data set in terabytes of size. So it became so popular because of its less number of lines of code, and it took the entire burden of writing the big programs. And pig is very supportive for a programmer, whoever is writing a query, because it is providing several built-in data structures, built-in supporting statements in order to see the data flow. And even more useful, it can perform a sample run on a representative subset of your input data, and you can see whether there are errors. This is the most important feature. Say for example, I have terabytes of data. I need not worry about taking the entire input at once, run my code. Instead, I can take a subset of the data set and run my code, and if it is working perfectly, then I can put onto the entire data set. This is just like a prototyping, work with a sample data input. And pig was designed to be extensible. These are all various features of pig language. Pig was designed to be extensible because it is trying to work with loading the data, storing, filtering, grouping, joining. Various user defined functions are built into the language. If we are not happy with the built-in functions, the user has the option to write his own functions. User defined function feature is also available in pig language. Now how do we install? Simply from this website, the original website, we try to download an appropriate version according to your requirement and then unpack the tarball, the installation file. Similarly, the bin directory can be placed in one of the paths in order to access it easily. Similarly, we need to set where exactly the Java home is existing. Now, whenever you are not knowing the syntax of any command, you can try typing pig-help, which will tell you how do you need to give the various instructions. It will show the sample syntax of the instructions. Then execution types. Pig has two execution types or modes, we call it. One is the local mode, the other one is the MapReduce mode. What do we mean by local mode? It works in the local machine with one single JVM, wherein you are trying to explore smaller amounts of the data sets, or you have a very small data set. When the input size is small, you can proceed with local mode. So how do we run in local mode? You need to type pig-x stands for execute it in local mode. The moment you give this one, you try to see the prompt, which we call as the pig grunt. And this grunt is the interactive shell wherein the user can start giving the commands. And what is the other one, MapReduce mode? I want to work with huge amounts of data sets and I want to work with very big queries in order to see the data flow and analyze. You go for the MapReduce mode execution, wherein you give pig-brief. The moment you give this, it switches into MapReduce mode. And pig reports the file system which is there in the local drive, not to the yarn. Pig never talks to yarn, which is the resource manager. It talks to the local drives on which it is executing. And how do we run the programs? And also whenever you are working with pig, it can run in local mode for data sets which are less than 100 MB. And if it is crossing, we generally go for MapReduce mode. And how do we run the pig programs? There are three ways of executing the pig programs. First one is the script mode, grunt mode, embedded mode. I will just quickly brief about all these three. Script, pig can run in a script file which contains all the pig commands. Say for example, you are typing the entire file and save it with .pig, stands for pig script. And all the commands one after the other will be taken and it will execute. Grunt is an interactive shell wherein you type one command after the other command and you execute. Third one, embedding. You can embed it just like a JDBC program in order to interact SQL. You can try to embed the pig script in another program. As part of our discussions, we will be talking about grunt, which is the interactive shell. So I am trying to work with smaller data sets. Now grunt has line editing facilities like those which are found in Unix versions, right? So you can just press the up arrow, it will show the previously executed commands and you can stop at the place where you want and you can try to edit your command. And grunt also remembers the command history. So you need not remember all the commands, just use the up or down arrow in order to see the previously executed commands. And one more handy feature in pig is you need not type the entire command, at least 2 to 3 lines you type and press the tab key. It will try to autofill the entire command. For example, I have shown A is equal to for each B, GE, later I press the tab. There is a statement or command called generate. So this GE, after this if I press the tab key, the command is automatically filled to generate. And say for example, it is already having some autofill options, right? You are not happy with autofill options, you can have your own autofill file and you can put it into the configuration. Say for example, I want to use for each also, I want to give an abbreviation. The moment I type FO, it has to translate it into for each. You can customize the auto filling options also. And also, as I told, you can get the list of commands using the help command in grunt shell. And what are the, once you finish working with pig, how do we come out? Just like you are coming out of shell script, you can either give the quit command, or you can just say the shortcut is \q. You can come out of the grunt shell. Then what are the editors with which we work? You have Eclipse, IntelliJ IDEA, various editors are there. You can work with any one of the things. Under sudo distribution with Cloudera, we work generally with Eclipse. Thank you.